Distinguished guests, ladies and gentlemen, good afternoon. Our event will begin in 5 minutes, so please be seated. To keep the event running smoothly, please kindly set your mobile phone to silent or vibrate mode. Thank you for your cooperation. Distinguished guests, ladies and gentlemen, good afternoon. Our event will begin in 1 minute. Our event will begin in 1 minute. Please be seated, and to keep our event run smoothly, please kindly set your mobile phone to vibrate or silence mode. Thank you for your cooperation. Distinguished guests, ladies and gentlemen, and of course our audience who joined us online, good afternoon. Thank you so much. It's my honor to be out of your host for today, and I want to welcome everyone to participate in Master Gathering over here, held by Taiwan Tech Arena and directed by National Science and Technology Council. And the topic for our Master Gathering today is the business opportunities in space industry. And we are really honored today to invite Master of Space Technology from Israel, and of course, low Earth orbit satellites experts from Taiwan. So we got a chance to share and discuss the opportunities for Taiwan in international space industry and markets. And we hope to excite our innovation thoughts and atmosphere here in the South. So, TTA South try hard to create a platform no matter for international experts and also Taiwanese business and company to share our experience and also exchange our thoughts on this platform. So we look forward to create more potential international cooperation. So that is the reason why we hold master gathering regularly. So at the very beginning of this event, let's welcome the important supporter of Taiwan's Technology, Department of Academia, Industry Collaboration, and Science Park Affairs, NSTC, Deputy Director General, Mrs. Jin-Yi Tu, to come onto the stage to deliver the opening remarks for all of this. Thank you.
Thank you. Good afternoon, everyone. I would like to, on behalf of the National Science Technology Council, I would like to address a warm welcome to all of you. It's our pleasure to have Director Lior Herman from Type 5 Israel, and President Wan-June Ma from Aerospace Industrial Development Corporation, President Richard Liu from Wipro, CTO Alex Chou from Rapid Tech, and all the friends and online guests here. Actually, the rocket booster on our satellite is utmost important when we talk about the emerging communication tech, like use emerging SOS via satellite on your mobile phone, and the Internet of Things, autonomous driving, and the global connectivity. Space industry is more important industry at Taiwan. The NSTC, our National Science Technology Council, promulgated the Space Development Act on June 2021, and we plan to promote Taiwan's national space brand, integrate cybersecurity into national defense. In order to strengthen our national scientific research and innovation capabilities, TTA South here will continue to attract international resources to space technology industry. Today, it's our pleasure to have Director Lior Herman from Israel. We all know that 2 days ago, there was a space tech summit to be held at Israel. Type 5 is a well-known venture capital firm at Israel and connecting top brands from all over the world, such as Meta, Apple, Microsoft, and so on. In the near future, we would like to, Director Lior Herman can organize a delegation to Taiwan and to have a virtual contact with us, since we do believe that both sides, Taiwan and Israel, has a lot of enterprises and startups could get more valuable inspirations and would like to have more contact with each other. I do hope that today's event will greatly benefit enterprise startups and emerging talents. TTA South will continue to cultivate university research development startups to provide business opportunities as a springboard for international expansion. So finally, I wish today's event complete success. Thank you.
Thank you for your warm welcome. Deputy Director General, please remain onto the stage, because right now it's our time for our group photo time. And of course, I want to welcome our distinguished guest to come onto the stage and join us together in our group photo number 1, which means we have group photo number 2. So first, I want to welcome President Ma of Aerospace Industrial Development Corporation to come onto the stage. President Richard Liu of Wipro. A round of applause. CTO Alex Chou of Rapid Tech. Welcome. And of course, never forget, we have an international guest online with us together. Let's welcome co-founders and managing director Lior Herman of Type 5. A round of applause. It's over here. So I also want to remind our photographers to get ready for the best photo shooting position. So distinguished guest, I'm your host for today, Miss Taiwan Joyce. So when I count down 3, 2, 1, I want to invite everyone to unbox the 4 box in front of you. We have a little ribbon over here. Okay. So when we count down 3, 2, 1, and let's unbox it together, and some magic will happen. You will see. Okay, are you ready? Ready? Okay, let's count. 3, 2, 1. Let's open the box. The satellites lift up with co-creation. Let's work it out together. And I want to invite our VIP guest to look at our photographers in front of us and show us your biggest smile. What about we have a thumbs up? And let's catch this precious moment together. We're so honored to have all of your support. Perfect. Thank you for all of your cooperation. Please be seated. Okay, and I'm talking about, we have 2 group photos. So right now, here comes the group photos number 2. I want to invite all of our distinguished guests to come join our photos together. So right now, our photographers will get ready onto the stage. We're going to take photos from these positions. And our audience in the back, let's have a thumbs up, okay? Give me a thumbs up, and if you have your mask, and what about we take off the mask and show us your beautiful and handsome smile. That's mask off. So if you're ready, that's 3, 2, 1, smile! And thumbs up. Our audience in the back, you can actually stand up so that we can see your face. 在我们最后一排的观众朋友们，还有我们嘉宾朋友们，可以站起来，然后呢，戴着口罩的可以摘下我们的口罩，露出您大大的微笑。So you can mask off and that smile to the camera and let's memorize this precious moment together. Thumbs up, smile. And let's witness the progress of Taiwan space technology together. Thank you for all of your cooperation. Thank you for your cooperation. And TTA South is really honored to invite Director Lior Herman of Type 5 from Israel to share the topics about aerospace industry 2030 with us. But before that, because our international guests are joining us online, so first, I want to make sure everything is going well and our devices are working properly. So, Mr. Director, if you can hear my voice, if you can see anyone, please wave your hand to our audience and give us your big smile and say hello to everyone. So everyone can hear our experts really well, okay? Okay, sounds perfect. So, louder a little bit. Okay, it's my turn to introduce you to our audience. So first, I want to give you a brief introduction about Type 5. Type 5 is a space tech investment group focused on solving humanity's greatest challenges with space to Earth. Revolutionary technologies that will lead the transformation of entire industries. So let's put our hands together and let's welcome Director Lior Herman to give up the sharing.
Thank you very much. Let me screen. So, can you see my screen now on a full screen? Yes. Yes? Perfect. So, hello everyone, and thank you TTA and all the distinguished members for inviting me to talk about the aerospace industry in 2030. I will talk today about what will be the future outlook that I see, and how today we can reverse engineer, as I say, this future and create a prosperity economy between our nations and the rest of the world. Is my sound is well? Everything is working fine? I can start the presentation?
Yes.
Yes, we can see.
Perfect. Okay, so as you presented, I'm the founder and co-founder and partner at the Type 5 VC, Israel's first venture capital that is focused on space, and I will tell you more about us today. The agenda for the presentation, just to give you a little idea, we're going to talk today about a paradigm shift, which is an important moment, I think, in human history that we are inside of. We're going to talk about how I believe the next 100 years will unfold. The Israeli venturing into space, I think it's a great case study because Israel is a newborn country, and I think that there's a lot of parallel with Taiwan that we have today in other businesses, and we can parallel to space. We're going to talk about the space economy, Type 5 global mission, and we're going to touch about Space Tech 101, as I called, and what are the essence of the new space industry and how we can utilize its economic value using a dual usage capabilities. So without further ado, the 100 years outlook of space, and I put this picture here because I think in 100 years from now we're going to have this type of vehicles, or maybe even better. But this is just to give you a glimpse into the future. Let's go into the present. I don't know how many here on the crowd have heard about the Fibonacci lines. The Fibonacci lines are mathematical sequences that existing in nature that has a mathematical pattern. And what's interesting about it is that you can see this pattern exists from the very small parts of nature, like seeds and plants and seashells, and up to the very complex structures of galaxies. The reason I put this as one of the opening slides is because not a lot of our time on the day is dedicated to understand really the essence of nature around us, and how things around us are built in patterns. And this is a little bit ideas for everyone that here with us today to start look at life and history and technology as a structure patterns and scaling from the smallest parts to the biggest that you can imagine. This is the space industry from the left in 1969, launching the Apollo 11 rockets into space. And this is just a little bit less than last month ago, the SpaceX launch pad of a Starship that unfortunately exploded en route. But the main difference between these two launches is that the one on the left is like a Boeing 747 that is going, let's say, one way from Tel Aviv to Taiwan, and then getting shredded and destroyed before it's going to go back. And from the right, we can see here a vehicle that is designed to land and to be reused to fly again like a normal 747 would. So this is just the beginning of to understanding the leap between the centuries, the 1969 and the 2023, that we moved from sort of throwing out airplanes to the trash bin to start having them land so they can be flying again to the next country in less than a few hours. To tell you a short story about my country, this is Tel Aviv in 1911. And we're talking about paradigm shift and economy of scale. This is a small street called Rothschild Boulevard. And in 1911, you can get here a cabin fairly cheap. You know, it wasn't a very expensive place. It was outside of Jaffa. a small settlement that laterly known as Tel Aviv. Today, this piece of land is one of the most expensive square foot of real estate in the world, and this is how the skylines look today in 2023, with a GDP area of $400 billion in 2022. The reason why I like this picture is because the settlement that we're building, this little street passage, I don't think that they imagine for such an economy of scale in less than 100 years. And it's not only in Israel, that's the beautiful part. This is a picture that I found on Google, actually, of Taipei in 1940. And it's really beautiful. It's a nice pedestrian. You can see here some horses and carrots and bicycles on the street. And it's very similar to my country back in the days. And when we're looking today at Taipei in 2023, I think it looks like a photo of a city from a different planet, almost. This is very important when we talk about the space economy, the paradigm shift and the growth that this industry is expanding is going to be in a few years, just like these photos of Tel Aviv back in the days and the modern city, and Taiwan of the 1940s, and this beautiful city that we have today. About a year ago, we met with your delegation with Taiwan capital and members of the government and venture delegation that came to visit our offices in Tel Aviv. We had a beautiful face-to-face meeting, but it's also nice to see everyone here on Zoom. And that gave the birth for today's lecture and for hopefully for capital and economy collaboration on space technologies. So I want to tell you how I see that this industry is changing by showing you this little kind of map of the space achievement since the beginning of the space program. And you can see here the little circles of the around the Earth that shows you what humanity has been done since 1957. And you can see how the circles are growing and what is being missioned out today. So in 1957, the Sputnik satellite actually launched the space age and the race for the big nations of the Russian and the US to start competing for space. That led for the Apollo mission in 1969 and future development of the space shuttle missions, and back in the mid-90s, the ISS, which is the International Space Station. This part is actually the governmental part. We're going to talk about it. And you can see how in the early 2000s, we already started to see a new circle that is unfolding, which is the private circle. SpaceX launched the Falcon 9 in 2010. In 2017, we had the NASA Artemis program to start to colonialize and building settlements on the moon and making space a sustainable economic zone, following by the Starship in 2023, and then orbital reef planning, which is the first private space station by Blue Origin of Jeff Bezos, and then launching into Mars. Now, the other vehicles that are in planning are including the Dream Chaser by the Sierra Nevada that is supposed to be up in the next decade. And even DARPA is moving on more exotic technologies. And I don't know how much of you here in the audience are familiar with DARPA, but they are basically the agency that developed the internet and a lot of the cutting edge technologies. In the past year, they've successfully proven that the physicality of warp bubbling around the physical object. And if some of you here have ever watched Star Trek, the propulsion that is described in this sci-fi show is warp drive. So we are in an age that the physicality of warp drive has been proven, and I think that the next next few decades, humanity will start to experiment on how we can utilize and engineer this type of physicality into actual drives. So to summarize the point, we moved from a first circle, which was completely government, combined into today's age, which is government and private. And then if we look in on the third section, which is the Artemis sections, Elon Musk and Jeff Bezos, and the future capabilities of interstellar technologies, we are actually going into fully privatized, propelled by the government, by a fully privatized space economy. And I think that that's what you should take away first when you start to examine the space race and you know, your place and your wish to be part of this new economy. So I will tell you a short you know, story about Israel in the space, starting from a very small example that brought Israel innovations to the world, was actually starting from the basic irrigation system back in 1965. Israel didn't have much of a technology, didn't have much of a developed economy, and it needed to have a flourish agriculture ecosystem. So Israel's one of the first innovation achievement was to build the irrigation pipe and the irrigation system that can replace water pipes and that can save a lot of powers for the desert parts of Israel, which is about two-thirds of the country. Later on, Israel developed a more agri-tech solution that obviously wasn't called that way, but it was agriculture technologies that brought the tomato, cherry tomato, the miniature tomato, to the markets and cultivate this to become a very popular food within the vegetables lines. And later on, when the internet area descended upon Israel, a group of entrepreneurs built the first instant messaging software that was known as the ICQ. I don't know how many here are from the 80s and 90s generation, but ICQ was bought by AOL for $400 million. And when that happened, Israel woke up to a new reality that a few kids in the garage with a few servers and ability to write codes can make a fortune by reaching out to millions of people worldwide and create new applications and features that are not even needing a physical manufacturing. But it wasn't the end of the manufacturing capability of Israel. Just a few years later, an innovator named Dov Moran applied the solid-state drive technology that was in its early days to a nice feature that we all know today as the disk on key. And his company, SanDisk, that was later acquired by $1 billion, created the first disk on key, the thing that we all have in our pockets today and using to plug and play our decks and other files. That's all started as a little startup from Israel. So, you know, we talk about paradigm shift and moving really fast from, you know, the space age to the internet age. We can see how a few successes brought a whole industry. And here you can see a map of huge companies that some of you maybe know, like Mobileye, that was acquired by Intel for $15 billion. Checkpoint, which is one of the biggest cybersecurity companies in the world, and others. And these, you know, innovations only happened in the past, you know, 10 years or a little bit more, and they all started because of those paradigm shift moments that gave birth for a whole new ecosystem. So, just like the internet in space, Israeli also thought about the innovation and how they can break through the barriers of cost and government. And just a few years ago, a few young entrepreneurs signed for the Google contest, the Google X Prize. And from that contest, they actually started to build the Bereshit lunar mission that became the Space IL and was able to raise $100 million from private donation and some government to send a private space lander to the moon. Now, I don't know if you're all familiar with that, but the lander actually crashed 10 kilometers from the moon. It didn't land safely. But the endeavor of Bereshit and SpaceIL gave birth to Type 5 and what we are doing today, and to the space tech era of Israel. And actually, a lot of the components that were designed for this lunar lander were later on spun out to be an independent startups that are doing landing gears, autonomous imaging processing for space, stars recognitions, and much more. So this is one of the final pictures that the lander took before it crashed on the moon. And it says here, small country, big dreams. And I think that even though that Taiwan is bigger than Israel, I think that every country starting in small achievement with big dreams, and nobody can understand or nobody can foresee what would be those achievements later on. Moving forward, we had the first Israeli astronaut named Eitan Stiva that joined the Axiom mission of SpaceX and was launched into space last year for a small ticket of only $50 million. I'm saying only because I believe that the experience and the experiment that he carried on board, if you take them to the private markets, they are worth at least $500 billion worth of spin-offs and technology development. So Eitan Stiva for me is a hero for the private space age because he had the courage to go as an independent astronaut, not even as a professional one, to explore the economic possibility, and despite of the cost and the risk and obviously the mental stress, he was able to do it and brought a lot of experiments and technologies into to the ISS. And he became the first successfully Israeli astronaut that reached to space after the Ilan Ramon Columbia disaster back in the 2000. And okay, so that brings us to Type 5 and what we are doing today. Type 5 is a group in Israel that is bringing the civilian age into the interplanetary economy. We are building a vehicle and transformational industries that wants to build technologies both for life on Earth and beyond. Today, we are collaborating with some of the biggest institutions in the world, like Toshiba, Honda, Northrop Grumman, Amazon, Microsoft, Mercedes, and Deloitte. We are looking at space from an area of what we call the dual usage. And you have to understand that a dual usage, what it means is that you're not only utilizing space technologies for the space exploration, but you're actually developing feasible solutions and feasible economies that will impact Earth today. So I'm jumping here to show you what of those examples are completely and how they can shift your economy in Taiwan. If we're looking today on the biggest technology company like TSMC and other Taiwan technologies, we see that I believe the next paradigm shift in Taiwan will be a space paradigm, because every technology that comes on board, and you can see here in this graph, delivers a new applications. It happened with as I said, with the internet, it happened with the cloud, it happens with AI, and now it's going to happen with the space. Those bridges will be, as Jeff Bezos and Elon Musk are doing today, I call it the Rockefeller of the space age. The reason I call it them this way, because they are the ones who are building the railroads, the modern railroads that will serve the space economy and will shift the applications and the products that we need for making this economy private and successful. Before I finish the presentation, I want to show you a few examples and to give you this quote from the General Stephen Quest of the US military, who talked about the feasibility and the need of the US Space Force. He said, it's not about the technology, it's about a strategy. Meaning that you may have, and our nations may have great technologies, but if we don't build the strategy around them and to how to utilize them and how to make them a space tech, economic viable, we will not succeed in this race. And I will give you the last examples before the time ends. So in upstream services, we have to develop a reusable rocket systems that are, economic and fast to launch. In the downstream services, we have to move from expensive and big satellites into miniaturized and what is called nano satellites. In the land stations, we have to move from expensive manufacturing and complex and long-term into a 3D printing and fast production. And all of these pictures are obviously from real companies like SpaceX, NSL, and the US company Relative Space that is the printing 3D missiles. So all of these examples are real and working. In Type 5, what we found is very similar objectives that are related to quantum technologies, to medical longevity, to energy, transportation, and networks. All of these technologies are fundamental for Earth applications and are only catalyzed by space, but their usage is on Earth. And I will show you how this dual usage or multi-usage is playing out. A few examples. This is a 1 gram of a crystal that Israel growing in space using a space lab that is able to grow materials to cure cancers and treat diseases. And each piece of that, it's cost $2 million per kilogram. So you can understand that if you're able to manufacturing those crystals in space, you have a very strong market for pharmaceuticals coming from space. This is another example of an Israeli vest called the STEMRAD that is actually protecting ISS astronauts from the radiation in space, and now is being utilized for light vest for medical applications. Another example is a company in Israel called Helios that developed a reactor for oxygen manufacturing in space, and now utilizing this reactor to actually making steel production more clean using its reactor to save all the coal burning and making the production more sustainable. And in nanosatellites, we see how Israeli companies are replacing a big hundreds of kilograms worth of weight by nanosatellites backhauling constellations that are saving a lot of power, cost of operations, and of course, speed and functionality. Last example is the cybersecurity. Israel is utilizing some of its Iron Dome technologies that are utilized to protect the nations from missile defense into creating a cyber protection that will prevent hacking into shipping, autonomous vehicles, and even industrial plants. So to summarize, when you think about space, you have to think about what industries and what challenges you can solve on Earth and how you can make it a sustainable business. Because in the end of the day, and this is the final quote using the time constraints that I will leave you with, is that space will become $1 trillion market for manufacturing, energy, and transportation and communication. It was said by General Stephen Quest from the US Space Force, and I want to leave you with that because if you understand that this is the biggest opportunity of our century, and you learn how to build the strategies and how to build the sustainability challenges, you will succeed and hope to collaborate with Israel and Taiwan and in the next few years and building this great economy together. So thank you very much.
Many thanks to Director Lior Herman. It's not about technology, it's about strategy. I believe after his sharing, you might get some curiosities or questions that want to ask, but don't worry. If you have any questions, we got chances. Mr. Lior Herman will join us next panel with us online as well. So if you have any questions, you can keep it and we can solve it during the QA session. So next, we will have our panel discussion first. Today, we are really honored to gather experts at home and abroad to join our master gathering here in TTA South. so that we can gather international views to explore Taiwan's opportunities and also industrial distribution in global low Earth orbit satellites. So first, I want to invite our moderator to come onto the stage. Let's welcome Miss Taiwan Joyce E. Su Chu, which is me. Thank you so much. I will be your host and also the moderator for today. So at the same time, I want to welcome our three honored panelists. So first I want to welcome President Ma of Aerospace Industrial Development Corporation. A round of applause and let's welcome. Welcome to come onto the stage. And next I want to welcome President Richard Liu of Wipro. Last but not least, I want to welcome CTO Alex Chou of Rapid Tech. So, first I want to recall the topic for today for everyone. Today, the topics, we're going to talk about the business opportunity in space industry. So before we start the QA session and we start the interview, I'm going to give you some short introductions about global space development. Okay, in recent years, global space development has become increasingly active, and all countries are actively developing space technology and related industries. According to the analysis of research and markets, the market value of the global satellites manufacturing and launching system is expected to grow from, it's US dollar, $22.7 billion US dollar in 2022 and grows to 25 billion in 2023. So you can find that it's a big growth and it's around the compounding annual growth rate at around 10%. So it's a huge growth. So among them, the application and commercialization of low Earth orbit satellites, we also call it LEOS, have become one of the hot topics. LEOS can also be used for various missions such as Earth observation, communication, navigation, and scientific research, and application fields including agriculture, environmental protections, and urban planning, which have a huge commercial potential. So this is some basic information about the global space development, because we also get students and our experts from different fields. So a short introduction will help everyone to get into the question deeper and easier. Okay, so our big topic for today is global space development, but we are going to talk about it in three fields. The first, we're going to talk about international development trends and business opportunities of low Earth orbit satellites. So we have a new noun over here. Low Earth orbit satellites, we also called it LEOS. So here comes the short introductions about what is low Earth orbit satellites. This is some little definition. Low Earth orbit satellites usually refers to artificial satellites with an orbital altitude below 2,000 kilometers. For example, small satellites, microsatellites, and nanosatellites. And what can they do? They can do a lot of things. They can be used for various missions such as Earth observation, communication, navigation, and scientific research. The application fields can be including agriculture, environmental protections, and urban planning. So as you can see, they can do a lot of things. So what is the advantage? They are low cost, high efficiency, and rapid development, excellent coverage, transmission speed, and interference resistance. So that the market for low Earth orbit satellites is also showing a rapid growth trend which have a huge commercial potential that it's easier for us to imagine. So here comes our first questions. And I want to ask this question for our President Richard Liu. So can you share your views on the competitive landscape and future development trends of the low Earth orbit satellites communication markets?
Yes, from our view about the landscape and the future satellite communication market, we see something happening. The first, before the LEO communication fully functioned. Now the first is the multi-orbit service, like combine the LEO, MEO, and the GEO together. Like currently the EU Intersat cooperate with the OneWeb, and the Intersat cooperate with the Intersat, and the Inmarsat combined with the Viasat. Okay, so this is a trend about multi-orbit communication. So the device can connect with the LEO and the MEO or the GEO together. Then the second we found is the modem. The modem is new thinking about the software-defined modem. So you can change it to the different constellation using the software-defined. So you can do the OTA. Yes, you can change your modem by software-defined. That's another trend. Also about the another thing is that we found is everybody is hot right now is about 5G combined with the 5G. We call the LEO is the 6G now. It's combined with the 5G. I saw that the iPhone mentioned about it will connect with the LEO. So it called a red cap. Red cap that do reduce capacity with using the 5G TNT protocol to do the communication with the mobile phone. So that is a big trend also. Yes, this is I see the trend of the landscape and the future market is going. Yes, thank you.
Thank you for your sharing. And you just talked about there are many different kinds of trends. So it's easy for us to imagine, like there are more and more companies who want to join this field one after another, and the competitive is really going increase because they got a lot of like commercial chances and business chances in these fields. And you just talked about a lot of new trends. So it's actually a good place for the company to get in. So my next question is also for our president, Richard Liu, because you as the president of WavePro, and how does WavePro respond to these challenges and opportunities to maintain your competitive advantage? Because there are so many competitors and they are growing and become more and more. So what will you like face those newcomers or like new competitive?
Okay, thank you. Basically, WavePro is not, we are not doing, we're doing a test equipment, test system to support the whole industry. So we don't directly make the product. So based on our company, we would like to, we found that, for example, the modem issue, we need to develop channel modeling of the LEO. A different way, the angle of the satellite, or the handover things. So we will develop this kind of test system for all the vendor to support them to develop their product. Also, we will develop more precise compact test range, because that is our core technology, is generate a compact test range for the satellite testing. And we had a patent. Actually, we granted a patent for a highly accurate compact range for the satellite testing. So this we will focus on to support this industry.
Okay, perfect. Thank you for your sharing. You're talking about the new technologies and patterns that we can help your company to like become stronger and stand tall in this kind of fields. Thank you. So before we go into our next question, I want to have a brief introduction about Aerospace Industrial Development Corporation. Then you will know why I'm going to ask an introduction before the question. So although AIDC is Aerospace Industrial Development Corporation, but it's just too long, so we call it AIDC. So although AIDC is famous for its aviation manufacturing, including the productions and manufacture of well-known FCK-1, 金国号 FCK-1. AIDC have participated in the productions of satellite structural components as early as 10 years ago in Foremost Satellites number 2. They also being reported that SpaceX has approached AIDC to discuss potential cooperation. Also, AIDC has also cooperated with National Cheng Kung University, 成功大学, to design and produce an external heat dissipation system upgrade. The rocket has successfully launched in November 2019, and currently AIDC's products, they have all been operating normally on the International Space Station and have attracted international attention. So, here comes the question. After this short introductions about AIDC, what do you think of AIDC's integration with the international space industry? And has AIDC also entered into the related international markets? So for sure, for our President Ma.
Yeah, thank you. And it's my habit to answer the question first of all. The answer is no, okay? And don't disappoint it. Let me explain. The major job of AIDC is to design and manufacture the aircraft, not satellite, not spaceship, not starship, just aircraft. It's since about maybe more than that, FCK-1. It's about 50 years ago. It's 50 years ago, yeah. As you know, I'm an old-fashioned engineer. I designed, manufactured, and tested the missile system for the past 35 years. And the latest 4 years, I was transferred to AIDC to design and manufacture the aircraft. So sometimes I told my friend, I tried to shoot down the aircraft for my whole life, and now the government told me to build the aircraft. It's very interesting. Okay, come back to your question. The main job of AIDC is to design the aircraft. The only difference between aircraft and the satellite or spaceship is altitude. In other words, the only difference is in the atmosphere or at the edge of the atmosphere or out of the atmosphere. No matter what altitude, the same thing is environment control. You have to face the environment. And inside the atmosphere, you must face the high density, high pressure, very noisy, very sticky atmosphere. And there's some engineering problem. But at the edge of the atmosphere or outside the atmosphere, you don't have any those problems I told you before. And you have a new problem, like space radiation, like vacuum radiation, like solar radiation, everything like that. Everything's like that. That's another kind of environment. So the only thing AIDC have to do is to change the environment requirement of the parts. So we can transfer the aircraft parts technology into satellite technology, or like our host said, we manufacture some parts in the International Space Station. There's a laboratory in the space station called AMS. Maybe some of people you know AMS, led by the very famous Taiwanese scientist called Ding Zhaozong. Yeah, some of the parts we manufacture for Dr. Ding, and some of the parts we manufacture for NSPO from Formosa 2 to Formosa 8. So the only difference thing in an engineer's eyes is the environment. So you told me this part, this heat exchanger is in the aircraft or in the satellite, or in the International Space Station. For me, it's all the same, only difference of the environment requirements. So if you ask me, have I entered the international supply chain or international space business? The answer is no. No, we didn't. Because in my definition, you come to a business, you come to an industry area, you must have a stable contract from the customer. Like we manufacture many parts for Boeing, for Airbus, for Bombardier, for GE. And that's a contract for 6 years, 4 years. How many $billion? That's the definition of we enter that business. But one parts, one contract, that's not, we haven't get into the international space industry like most of the Taiwanese business. It's only a startup. It's only a beginning. And it's a light over there on the horizon. And we must go for it. We haven't, I don't know any company really get into the international space supply chain, become the supplier of a stable contract with NASA or SpaceX or Bezos. I don't know, but at least AIDC not yet. We are still working on it. Yeah, thank you.
So some further little questions after that. So AIDC didn't, but will AIDC going to do that? Or do you feel like doing that? Yes, right? We're looking forward to it because you're so close. You're so close. Okay, thank you for your answers. And we just hear from the insights from experts from Taiwan. So what about Israel? We have the experts from Israel. So next question, I want to invite Director Lior Herman to share the opinions about how Israeli space technology companies innovate and transform from the perspective of technology, products, and markets to cope with the ever-changing market environment and competitive pressures. Do I need to repeat
I can hear you. Can you elaborate a little bit just so I answer to the point about how the innovation you mean by examples or?
I think both examples or rough ideas will be good for us. Maybe some rough introductions and some concrete examples will be easier for our audience to understand.
You mean the commercial opportunity of the space tech companies, right? I just make sure that I understand you well.
Yeah, the question, I will repeat the question again.
Yes.
How Israeli space technology companies innovate and transform from the perspective of technology, products, and markets to cope with the ever-changing market environments and competitive pressure?
Yeah, that's a good. Now I understand it better. I think that's the most important part of the space innovation. I'll give you one example. One of the space tech companies in Israel is called Astera. It was actually not founded by space professional. It was actually founded by geologists. That their experts were about analyzing geographic imaging and to finding water resources in different type of soils. And they were wondering if they can use this type of knowledge to find the water signing on Mars for understanding the planet history and understanding also if there are still water hidden in some areas that we haven't detected yet. So they utilized this technology and it worked really well. It showed some areas of water streaming. And then they understand that if they are taking their algorithm and they are reducting them to see where the waters are not streaming according to their system, they're able to actually detect the water leakage in cities and in a big industrial water systems. So they took their water diagnostic system that was built for researching the planet of Mars, and now they're able to save cities and municipals, governing areas, millions of dollars a year from lacking of infrastructure and damages of infrastructure because of their detection algorithm. So I think this is an example of how we can innovate today in space and utilize that smartly on Earth.
Yeah, so far I think we get the insights from our experts from Taiwan, and also we got the insight and examples and the rough ideas about what's really going on and how can Israeli company and innovation company to deal with the pressures and this kind of challenges. So still remember, we're going to separate our big topic into three. I want to remind everyone, the first topic we're talking about is international development trends and business opportunity of low Earth orbit satellites, right? So right now it's a little wrap up for topic number 1. So we're going into the topic number 2 right now. The topic number 2, we're talking about the entry points for the Taiwanese corporation, because topic number 1, we're talking about the rough idea, the international development situation. Right now, what about Taiwan? So topic number 1, the entry points for Taiwanese corporation. So first, some short introduction as well. The rise of low Earth orbit satellites business opportunities has also driven the expansion of non-geostationary orbit satellites. We call it NGSO, non-geostationary orbit satellites. Ground station and the expansion of the end consumer application equipment markets. Among them, NGSO satellites ground stations have been deployed by major satellite operators around the world. With the increasing demand for orbital satellite ground stations, it is estimated that the output value will reach $67 billion by 2030, which is a lot of money. For sure, equals to a lot of business opportunity. In the past, Taiwanese manufacturers have established a complete professional manufacturing driven and supply chain system in the manufacture of key components such as network communication equipment and semiconductor. Like Taiwan is not good at that, so we have a really concrete and nice base on that. So, in the assembly of small satellite stations, they can meet the needs of international satellite operators for flexible manufacturing and competitive production cost. So, right now, next questions goes to the CTO of RapidTech, Alex Chou. I want to ask, for the development of low Earth orbit satellites, RapidTech has joined hands with the Rotoswat and also Whispack Technology to build an advanced antenna lab. And also your manager talking about that in the future, it will do the 3 product lines of millimeter wave testing, advanced RF R&D center, and also automatic design to meet the customer needs. So here comes my question. Can you tell us about what this lab mainly wants to develop, the antenna lab? And also, in addition, can you also introduce to us the Cube Satellite Testing Laboratory established with NCU? You cooperate with National Central University, so we want to know more information about that. So 2 little questions.
Okay, thanks, Joyce. Before my feedback these questions, first of all, I wanted to echo what Herman just mentioned in the slide. This is not only related to technology, but also strategy. As you just mentioned that, first of all, I believe that we established the next generation antenna test lab in 2021. And in a later, at the beginning of this year, sorry, it's 2022. And in the beginning of this year, actually, we start from the end of last year, we established the CubeSat satellite laboratory and research centers in Qingpu, Taoyuan. Why we do that? Because not just only, not like to the most of the company in this industry, what I mentioned is the space industry. Most of them have several years and decades in this industry, but Rapidtech is a newcomer for this industry. So once we started to jump into this industry, we need to think about what is the unique technology we have. And we need to strengthen this technology. So this is all related to strategy, right? So the first thing the unique technology Rapidtech have is the phased array design. How do we optimize or to provide the optimal service to our customer is that we can help our customer to optimize the custom phased array design to satisfy customers' requirement. This is the first step. That is why we established the next generation antenna lab last year to service our customer. And to be honestly, for last year, maybe April 2022, our customer used Rapidtech's antenna design for satellites. Already, the satellite has already been launched in April last year. So this is the first thing we think about. We need to conquer the specific or very unique technology we had and to strengthen that at first. And the second one, we are thinking about, as Herman just mentioned that in the near future, or maybe the communication system for the QBC applications is coming very, very significant improve in the future for this industry. To not just only for this industry for maybe 10 years ago or maybe 20 years ago. The QBSat, we are focused on, what we mentioned is the technology or QBSat is mainly focused on the microsat or even nanosat or picosat. Many focus on maybe the weight of the satellite must be less than maybe 20 kilogram. And what we wanted to is that we established this research center with National Central University is mainly because we wanted to shorten the learning curve or experience to enlarge our experience in this field. That is why we established a lab in Chimpu, as I mentioned, to cooperating with the research institute to shorten the design cycle or even though to shorten the learning curve for our company. And also we cooperating with TASA, which is the National Taiwan Space Agency in Taiwan. They will have, in the future, right now, actually, they do have the project to cooperating with Taiwan company to establish the QBSat technology development. So I think this is my answer to feedback the question you just asking, right?
Perfect, thank you. And I want to extend the question a little bit because you cooperate with the university, Central University, right?
Yes.
So I want to talk more about like the talents and education cultivates and like why you want to like cooperate with the university, or what is your ideas or what is your concept about cultivate high-level talents in the space technology?
Okay, I think for space industry, not just like for the conventional communication system or double electrical engineering, communication engineering, the space industry or space engineering is a very, very niche topic, even though not just only in Taiwan, but even though around the world. So what our strategy to establish this research lab and also to cooperating with research institute is mainly to cooperating with not just only the professor in this field, but also the specific student in this field. As you can imagine, in Taiwan, most of the education institute, most of the students, they just only to strengthen their knowledge or theoretical knowledge when they just study in the school, right? But the most important thing is not industry. If we wanted to shorten as I mentioned, shorten the development schedule or to shorten the experience, that the most important thing to cooperating with research institute is that we give them a project cooperating with the professor. And by involve by give some student to maybe more like interns projects with them. And the good news is even though during their study in the school, they already have the experiences of what differentiation between the theoretical and the real applications. If you wanted to develop the project or develop the product, because most of the students, they just only know the theoretical analysis in the lab, in the school. But if we can just cooperating with the research institute, there might be a chance that that kind of student, this student to understand what industry need and what the most important thing is what will their, the opportunity they have. Because when they're in the school, they already know maybe in the future they can work with us, right? This is what we wanted to cooperating with the research institute and also to work with the school, with professor and student that they know not just only for the theoretical, but also the real practical applications to shorten, as I mentioned, the main purpose is to shorten the design cycle or maybe the learning curve that they can very rapid to approach the real projects and to understand what this industry, the space industry needs. Yeah. Thank you.
Okay, and I guess from your answer, I get to know that the Rapid Tech is the best is examples about the sentence, not about technology, it's about strategy, and also not about theory, it's about do it by yourself, right?
Yes.
I think this is the main, very important point to cooperate with students, professor, and university, and those learning institutes.
Yeah.
Thank you so much. And next I'm going to ask more questions about WavePro, but before that, I need to have a short introduction for everyone, and that more people know more about WavePro, then you will get the meaningful of these questions. So, as we know, WavePro founded in 1993, which is 1 year older than me, is Taiwan's first microwave test design and manufacturing system integration company. And it has built more than 170 microwave measurement fields and dozens of compact antenna tests range, we call it CATR, around the world. So this question will go to, for sure, our president, Richard Liu of WavePro. As Taiwan's first microwave test design and manufacturing system integration company, can you introduce to us what microwave test technology is? Like, what is microwave test technology? And why it is so important in satellite-related development? Besides, are there any other topics that is suitable for Taiwan's manufacturers to enter the international space supply chains besides ground equipment? I know it's a lot of questions. Actually, it's 3 little questions, so.
Thank you. Thank you. It's a long question.
Yes,
but,
sorry.
Try to have the first question to be short because it's about my company. Okay, WavePro is actually the first microwave system integration company in Taiwan. I established this company in 1993. I just left Zhongshan Institute. Okay, and even I left the Zhongshan Institute, all my job is related to Zhongshan Institute. So I feel I'm still with the Zhongshan Institute. Okay, this company, yes, also the Dr. Ma is the same. He is my boss. Not really. It's not boss. It's 我的前辈啦。对，我的长官。Okay. So we developed. I set up this company because we want to stand up from a different position to support the defense industry in Taiwan. So for the missile, currently around 80% of missile of the Taiwan calibrated by our system to be the calibration and also the antenna measurement, this kind of thing. So this year is our 30 years anniversary. Yes, okay, this is our 30 years. And about the satellite, yes, the compact text range. I was the compact test range lab manager in CSIT. Actually, I did the radar cross-section measurement for the IDF, the GD53. I need to define the RCS of the FYE to accept the GD53 radar for our IDF. So all my entire life is about defense. But the satellites actually very similar to the defense because the accuracy they want is pretty precise and is pretty really need a very precise plane wave to have a very low side lobe measurement, very precise beam width, very precise side lobe level. Because the satellites, especially low altitude satellites, so in the past there's geoset. You just look at the satellite. You lower down the side lobe, you won't see the different satellite. But now, in the future, so many satellites flying on the space, over space. So you need to very, very precisely to point into the satellite and reduce the clutter, the interference of the other satellite you don't want to communicate. So this would need a very precise test range. And based on the defense experience for 30 years, we can go to the satellite. Actually, in the whole world, currently in Europe, in India, in US, all they doing the satellite testing in the compact test range, the large one. And that's my dream also. I want to set up a large compact range for our Taiwan to be able to support our satellite testing. Also the UAV, like the UAV. Now the UAV we need to be the very low RCS to be a stealth to defend our country. So this technology need a very large compact range. And for Waypro, we developed. Waypro is pretty famous in the outside of Taiwan. Actually, we are more famous outside of Taiwan. We are tier 1 company in Europe, in US, and everybody know about Waypro. So this is my dream to set up a large compact range for Taiwan. Okay, thank you. This talk about my company. And then the second question is about the opportunity or the trend.
Here comes, the first question will be introduced, and you already introduced the brief introductions about your company. And the second, okay. And why it is important in satellite-related development.
Okay. It's definitely because I answered this already. Yes, because the satellite you need to be very precise at pointing, and you need the various satellite not to interfere into other satellite. I remember the second question is about the future.
Third question.
The future of the Taiwan, the opportunity, right?
Yeah, that is also part of the question.
Okay, I think we talk about the space industry. Actually, from my viewpoint, because the billions talk about a billion. Actually, I think that Taiwan should focus on the ground-based unit, the terminal, user terminal. Not definitely we need to develop space technology. That's no doubt. But in the future, the major opportunity and the major income will come from the ground-based unit, from the user terminal. Because especially Taiwan, we have very strong, very good opportunity because we are IT, we are a country for very strong electronics and IT. So this will be our opportunity. So from my viewpoint, we have few four things Taiwan we can focus on this space industry. The first is we have a very good engineer. We are smart. In the whole world, we are number 2, only 0.01 less than Japan. I saw a report just a few days ago. We are smart people. We have smart engineers and working hard. So the first, I think we can have software opportunity is auto tracking software. Because in the future, just you can see the 10,000 satellites flying. You need the very good auto tracking software to control your terminal or your ground-based unit to tracking the satellite. So I think this is our opportunity to do that, especially in the Taiwan, our young engineer. The second is about because we are very strong about semiconductor. So about also the IC design, I just mentioned about the modem. So we should be able to develop the modem by ourselves for our own use. Because the modern thing is very interesting is like the specs, they have their own modem. They won't share it with you. Okay. The modem is a standard already there. So, but you need to develop your own modem to solve the channel modeling, the fading issue, this kind of thing. And you can define your own software-defined modem. So I think this is our Taiwan opportunity because we are so good. Okay. And third is about in the future, I think in the future, the ground-based unit will be very cheap and very easy to manufacture. It's just like in the computer. I remember when I was graduated from my university, the Apple II, you can go to the Zhonghua Shangchang, just purchase something, put it together, then you can have a computer. In the future, that will be the same thing. Okay, so the ground-based unit, it will be modularized, everything modularized, antenna modularized, amplifier modularized, beamforming IC modularized. So who will make the money? The module. Okay, so the Taiwan, we are very strong on the semiconductor. So we should develop the module of the this kind of a module, no matter even the millimeter, that's no problem for our current IC design technology. Currently, is most two players is a Nokia wave and the ADI. So Taiwan, we should have a company. We are Taiwan. So we can develop our own module. So then in the future, we sell the module to everybody to assembly the user terminal. Okay, this is, I think this is a very important thing. The third is, the last will be the packaging. Okay, because you have this module and then you can develop the material to more understanding the material, no matter the radon or the PCB, the material, and do the packaging technology. And this, all of this integrate together, then we can have a very strong ground-based unit, and that will be a huge market. That is the really huge market. In the report, is around the 35 or 40% of the whole market is ground-based unit. Yes.
Oh,
yes.
That's a lot.
Yeah. So I think that is our Taiwan opportunity. Okay.
Oh, perfect. After your sharing, I do see a really bright futures of Taiwan, and also we can get a sense of a lot of entry points for Taiwanese corporations, right? Okay, and for sure, right now I know a lot of our audience, we have like students, and we also have our like leadership from different companies, and of course, we also have a lot of startups company. So here comes our topic number 3. We're going to talk about the opportunities for startups in the satellites industry, because like relatively it's low cost. I'm not so sure. It's still really expensive right now, but in the future might be low cost, short cycle, and quick response. So it is regarded as an important breakthrough in the development of space commerce. So it will be like a really huge chance for a startup company to get into the cycle and space business. So I want to ask President Ma from AIDC. So in response to the future trend of satellites demand shifting to lightweight and low cost, do you think this topic is suitable for development for startups?
Yes, the answer is yes, because here comes the reasons. I cannot agree more than President Liu just said. And another concept, just like a little bit like Dr. Liu said about module and the package of a satellite or space vehicle. In my daily job is to, I don't know how to say that in English, 国际国造. 国际国造, okay? I always spread an idea that the most important thing of 国际国造 is to design and manufacture our own, we call system parts. Not module, not package. In satellite, maybe it's called module. In aircraft, we call system parts. What is system parts? The computer, navigation module, landing gear, engine, radar, all these things in the aircraft. That's the most important thing. So, here comes the chance of Taiwan. Can we design and build a next generation fighter or a next generation trainer? Can we? Yes, but only by AIDC, not for the startups. But the most expensive thing in the national aircraft market is not the aircraft. Are you going to fight with Lockheed Martin? No, you can't do that kind of fight. But the system parts, or President Liu said, the module, the small scale, high density of technology. That kind of parts is the most popular thing in the world market. So this is the chance of Taiwan, and this is the chance of the startups. I have to say something about these things to young startups. You must have unique technologies. You must have something, what? It's normal. Well, I have a new one. Am I saying something wrong?
Maybe too correct.
It's not, is that a hint? Okay, let's come back to the topics. You must have something unique. You must have something other people don't have. Korea, they don't have. India, they don't have. Japan, they don't have, but you have. Where it comes from? From your brain, from your learning, from your education. We have the best education system. Don't laugh. It's true, we have the best education system. I never feel we don't have new incomers of the aircraft business. There are very, very many young people waiting there, well educated, full of ambitious, come to every business. We have very good education system. We have very brilliant young engineers. So create something other people don't have. Very solid technology. That's the solution of everything. The host said about the small scale, lightweight. That's not means of the composite material structure or sophisticated machinery. No, that's something of communication, navigation, other shin. There are more and more. Dr. Cao, that's my classmate of my university. Yeah, remember when we were college classmate, how big is the computer we use? Like this room. And what's the size? Yeah, don't you know that?
I didn't because I'm not your classmate.
Yeah, but everybody's classmate use that kind of computers.
You mean this big?
Days. Yeah, this big, this house. Yeah, and the speed is about half of your cell phone. So now the computer, the size of the computer is like your cell phone. That's a computer. So everything is getting smaller and smaller and minimized. So the satellite will getting more and more small scale. You are talking about LEOs. That's a shortcut we get into the space business. Are we going to launch the Apollo 11, Saturn V rocket? No, we can't. It's 1969, but it's 2023. Still, we can't. But we can build LEOs about 100 kilometers high and very cheap and very small and very, very functional satellite. That's the chance of Taiwan. And the startup, for the startup, your chance to get some kind of technology, like Mr. Zhou, like Mr. Liu, get some kind of technology created by yourself, not by the technical transfer from some big country. No, by yourself, and you will get something in this market. At the end of my comments, I would like to learn Mr. Chou to modify that sentence. Everything is decided by not technology. It's not about technology. It's not about strategy. It's all about government policy. Okay, so when someday our government told us space industry is not important, all those things will stop. So let's all push the government to stay this space policy. Okay? Thank you.
Thank you. And I think we can all work it out together from business, from governments, me as a host and moderators. We can all work it out together and be really confident because actually we got chances, and even like small startup company, we still got chances because yeah. Okay, so right now I want to kind of update what is going on in Israel right now because the space industry in Israel is developing really fast. We know that in 2019, Israel's lunar probe, I think it's Bereshit, I'm not so sure about the pronunciation, Bereshit was the first to send a lunar probe to the moon relying only on private funding and technical capabilities. So the first one, only by private funding companies, so which is quite impressive. Although it was not successful in the end, but this experience has inspired Israeli technology company to invest more in their space business and their space markets. So according to the statistics of Startup National Central, an Israeli startup organization, there are currently about 50 companies and academic research institute active in the field of space technology in Israel. So this is just some like easy wrap up with what is going on about like the space business and the space markets in Israel. So for sure, our next question will go to our director, Lior Herman. So I'm curious about what are the advantages of Israeli startups in the satellite industry comparing to other countries or maybe comparing to Taiwan. How can Taiwanese startups develop their own advantages? What is your suggestions, or do you have any ideas to share with all of our Taiwanese startups?
Yes, thank you very much. I think that first of all, each country in the space, and not only in space, is gifted by natural resources and also natural challenges, and those natural challenges are developing and helping to propel the state of the art of that country innovation. And I think if you look at the Taiwan economy and Israel economy, you find some similarities, but you obviously find some differences that are based on the culture, on the country, on the region, and so forth. So I'll give you an example of how Israel utilized the innovation, and maybe we can compare it and parallel it to Taiwan, is the nano-satellite industry in Israel. So when Israel first became a space pioneer nation back in the early 80s, One of the challenges of Israel is because of its locations on planet Earth, it has a geographic location where if it wants to launch its own satellite via its own missiles, which is usually been done by the the Earth direction, the launches are to the east in order to go through the atmosphere and go into the Earth orbit. You usually launch to the east, but in Israel case, we are surrounded by countries that would not with all of them we have today peace agreements, although this may change in the future, but now it's a challenge. So Israel had faced a geographic spot where it needs to have a very lightweight missiles, and it also needs to have a lightweight satellites in order to reach orbit in the sending on the west direction, meaning towards the Mediterranean Sea. And that actually propelled the innovation of nanosatellites in Israel to become much smaller, lightweight, and efficient. And from that innovations of learning how to develop smart and reliable nanosatellite industry came companies, private companies like NSLCom, for example, that using a miniature sail in space that is open from a nanosatellite and is actually able to transfer communication. It's called backhauling, just the same way that old TV satellites used to do back in the 80s and 90s with a few tons of weight and a few billions of cost worth of satellites, and they're able to do it worldwide. So I think those two conditions of needing to have a lightweight launching and the expertise in developing nanocube sats is developed the innovation. So I'm sure that if we take this example for a Taiwanese market, we can find similar challenges that maybe the defense industry was facing, or maybe a different industry, and how that propelled into a space application or space innovation.
Okay, thank you for your sharing. So right now we got more information about what's going on in Israel, about their startups situations, and also we still get a lot of opportunities from Taiwan, because like different countries, we depends on different countries, we have different challenges and different benefits. We always can find like what we are good at, and the most important, we need to come up with something from our brand. The unique technology is really the key. Thank you for all of your sharing, and I'm really happy that you share more than I ask. So which is good. I think our audience are really happy about like getting new information, right? Perfect. So here comes the QA session. So right now, if you have any questions, I believe this is the best opportunities for all of you, because we gather our experts from Taiwan and also abroad. So this is your best opportunity. So if you have any questions, please raise your hands and our staff will give you the microphones. Don't ask me as well. I'm just the moderator.
Mr. Herman, I have two questions for you. Can you hear me?
I can hear, but maybe somebody will need to repeat it. I hear it in an echo, but yes, go ahead, please.
No, I think so. Can you hear me now?
Yeah.
Can you hear me better now?
Yes, now I can hear you clear, yeah.
Okay, I have two questions for you. Number one is, you mentioned about nanosets, and there are also other LEOs like microsets and CubeSats. Are they standardized, commercialized product, or will never be that way? I think, in terms of business development, this is very important. And my second question is, in your slide, you single out 3D printing in space manufacturing. Is there a particular reason for doing that? Thank you very much. So do you have my two questions now?
Yes, sure. So to your question, yes, first of all, the nanocube satellites are commercialized, and they are built to be able to produce them in scale. I visited one of their manufacturing facility, and the assembly line is that way that you can develop a serial type of CubeSats and then built on top of them different sensors and different capabilities, like a little, transformers that each of them can utilize its own special functionality that is required from him, from that CubeSat to do, or to work in conjunction with other neighbor satellites that is part of a constellation. The second question that you had is as far as the 3D printing, which I see as a critical component for space from two reasons. First, the future of space industrialism is to be in-orbit manufacturing, meaning we will not have to launch into orbit a nanosatellite. That will be too ridiculous in a few years or maybe a decade. You will have a 3D machines that will be able to just print the skeleton of the satellite and a small assembly line in orbit that will be able to just drop the satellite in the right location and make it feasible within a few hours if needed. And those will be critical for weather prediction, for cyber, for communication, for healthcare, and many different other purposes. And also the other reason why I see 3D printing as such a critical component is that today we have a new revolution that is coming, which is the AI, the artificial intelligence. And one of the things that we see that the artificial intelligence has the ability to create designs and create a structure that are much more feasible, much more strong, but much more complicated to produce with current state-of-the-art manufacturing that has nuts and bolts. So when you have 3D printing, you're able to create much more sophisticated structures that are more durable, more strong, and also more efficient for space exploration. So this is why I see that happens, and even in the long term, I even see 3D printing in space that are printing skeleton for spacecrafts, and that will be a huge hangars, but that will be the far, far future.
Yes. Okay. Hi. On behalf of NSTC, I would like to ask about Dr. Herman about what in the investor perspective, what's your view the most important criteria that you think is a kind of for startups to have a not mentioned about the strategy or the capability of technology or something like that. What's the important criteria that you view startups to launch their business to space industry? Thank you.
Maybe somebody can repeat. I think the question was about material.
Yes, I would like to ask from investors' perspective, point of view, since you, yes, your company is like a venture capital's company.
Yes, yes. So you're asking, so you're asking what makes the investment more feasible, right?
Yes.
So that's a very good question. You know, the complexity of analyzing a space investment deal is very, very hard today because it requires a three-sum game. The first one is obviously a very exciting innovation, the one that has an impact on broad industry and has a vast economic potential, which is, you know, it's true for every startup, but the two others are the most important. The first is that the ability to work in the government environment, meaning even if the startup has a great idea, or let's say a quantum sensing radar, but this system, for example, is not going to be DoD approval because of, you know, national security or communication frequencies or anything that is related to critical infrastructure. So that the government part is super critical, and one of our senior consultants in Type 5, which is what makes our group very, you know, unique and diverse, is that we have with us on our team one of the senior members of the Israeli DoD that is also work with the Israeli grant program for space technology. So this is the second component that is enabling us as investors to make sure that whatever we want to invest in has the government and the regulation and the feasibility to operate. That's the second one. The third one, which is I find the most critical for the final ticket of investing, is the ability to find a midterm revenue channels that are not space related. Meaning Astera, that I just gave this example in the last question or so, if they were trying to raise money to explore the surfaces of Mars or Jupiter for water, I'm not sure if they would be able to raise money. But once they start to sign in on contract with municipal cities and governing areas around the world, and in helping them to decipher where they have a leakage program and infrastructure problems in the region, they started to generate revenues, and that's where the company can grow into scaling and winning eventually a big NASA contracts or ESA contracts or Asian contracts for space. So the dual work with the Earth industries and the short-term capital and the ability to explore space in the long run, that would be the third and last important component that we see as an investor. The ability to enable other industries. That will make space sustainable. And just to cap on all of that, the general that I quoted in my presentation, Stephen Quest, he said something very important. He said that the automobile industry was pushed by the government back in the end of the 18th century, where Henry Ford was manufacturing the cars to be able to make it on mass production. But the reason that the automobile industry succeeded is not because of the government subsidiary. It's because it had a great financial vehicles like leasing for cars, and then that it helped people to get more jobs and to propel and to ship a product. So that is how we have to look at space. We cannot look at it anymore in a just scientific or governmentalized. We have to combine both and to create this economy in order to stay competitive also. So thank you.
Thank you. I think we got a short period of time to open up for our last questions. Is there anyone got questions? Just raise your hand. Okay, perfect.
Hello, everyone. Well, my question is in relation to the LEOS, the fact that it's affordable, and it means that multiple of them can be launched into space in a shorter period of time, which means that opens space for space traffic, right? So I'm more of an environmentalist, even though I'm a business person. So my question is, has there been any developments in research in terms of traffic management? And yeah, basically, yeah. That's my question.
But, do you want to invite any of our experts or?
Yes, I do, Mr. Yes, please. Thank you, sir.
when my hand stops, just let me know. Just kidding.
Yeah, you can imagine it. Few 10,000 satellites flying on the space. Definitely, there's last year we have a Lior delegation to U.S. To visit a company in U.S. And I was the group leader of the Lior delegation last year, and we found a company that they already developed a software to do this kind of a service, to let you know where is the satellite. They have you can go to the web, and later I need to find out the web. You can go to the web. You can see currently the whole world satellite, the position of the whole world satellite. So that kind of software can be given the satellite operator to know who are around you and the direction of this kind of thing. So this kind of they can change the path. Okay, so Yes, they already have this kind of technology already developed. You have to, yeah. Did you mention about the environment?
Maybe I can say something about that. You know something? Everybody talking about LEOs, low Earth orbit satellites. There's a good advantage nobody talk about LEOs. Because LEOs, the orbit is low. So there are still atmosphere. So the orbit of LEOs will decay very quickly. So I don't know the life cycle of the LEOs exactly, but it must be less than 5 years. It will decay. So it's business. You need a lot of LEOs, okay? Because it will decay very quickly. So it will not become a space trash. It will fall into the earth. But don't worry. It will burn out. It will burn out before reach the ground. So
I'm about to worry.
Yeah, don't worry about that, because the minimize, just like President Liu said, it's minimized, small, it's lightweight, so it will burn out, and it will not become a space garbage. Okay, so it's a good advantage of LEOs. And I take this chance, I have to say something more, not about that, about another thing, about policy. The job of the government is to aim high, set a high level goal, and those big industry, big business, or small company, or startups will follow that goal and will reach high. So the policy of 国际国造 is good. So the policy of our space industry these years is good because it's aim high. What is the bad policy? The government is first to say, oh, this is too hard. We are not going to develop that. That's aim low. So we'll let the government set an aim high policy, like these days, aircraft industry, satellite, space industry. This is an aim high policy. So that's good. Any kind of government policy told you will not develop that because this is hard. Maybe 40 to 50 years ago, some of the government will tell you the chips is too hard. We'll never have a TSMC these days. 40 years ago, when I was a graduate from college, I witnessed the development of our chip industry. So aim high. That's the responsibility of government. Yes, please. Thank you.
Thank you. I think it's not only for government, for everyone. We need to aim high, that we do more and more and go further and further. And what a lively panel discussion. So I want to invite everyone to give our experts on the stage a round of applause. Thank you for all of your sharings. And I believe that all participants really get more information and more knowledge about our master gathering today. And the topic is talking about a business opportunity in space industry. And once again, thank you for your participation. And on behalf of TTA South, I want to share with everyone that we try hard to build a platform for everyone like this, we can share our ideas and exchange our new methods and what we are going to do in the future. So that is the reason why we host master gathering regularly with different topics. So every time we will invite masters from different fields and also abroad to share the ideas together. So if you want to know more information or if you want to attend our next master gathering with us over here, so please feel free to check our Facebook fan page and also our official webpage. And if you want to review what we are talking about today and our topic today, we have our online live on our Facebook page. So feel free to come onto the Facebook page and like it and track it. You will get more information and you won't lose any of new information. So next, we open up for a free discussion. So I want to invite everyone, don't miss this best chance. No matter you want to talk to our masters, our experts, or also your neighborhood. I believe that is the best chance for you, and I'm so excited to see if we can have some new ideas or like fresh plans coming out from our master gathering. That will be super cool. And I'm your host for today. I'm Miss Taiwan Joyce. Thank you again for all of your participation, and I want to wish you a very good day. Thank you for your participation.